Hello everybody, Nikita Iremin here, and today we'll be talking about strings, branching and iteration in Python. Strings in Python are sequences of characters. String can contain letters, special characters, spaces or digits. To mark a value as string, we should enclose it in quotation marks or single quotes. One of the most common operations with strings is concatenation. That's when you add one string to another, producing a new string. Here's an example. We assign string hello there to a hi variable, then string Anna to a variable called name. After that, we create a new string concatenating values of hi and name variables, putting the result into a greet variable. We also can multiply strings by integers. That produces a new string consisting of original one repeated as many times as we specified. Here's how you can use print statement with strings. If you have values of different types, you can specify it as separate arguments to print. Another way is creating a concatenated string of everything we have. However, in this case, we need to convert numbers to strings before we can use it in concatenation. Let's consider a typical scenario of console application. Script prints something to console and user is to enter some value. Then some calculations are done using the value provided by user. We can use Python input statement to read the input from the console. The string param we pass to it is printed on the screen, and everything user types in until enter key is pressed is returned as a string value from input function. Please note, in case you're reading numbers from console, you need to convert it explicitly to number type to be able to use it in calculation afterwards. Let's see which comparison operators can we use in Python on numbers and strings. These are greater than, greater or equal, less than, less or equal and not equal operations. The result of comparison is always a Boolean. It's true in case the condition is met and false otherwise. We also can perform logic operations on Boolean values. The common operations are the following. Logical NOT, producing the opposite value of its argument. Next is logical AND, which returns true in case both operands are true and false in any other case. Logical OR returns true if any of operands is true and false in case both of them are false. Here's an example of comparison. Having assigned 15 to psat time variable and 8 to sleep time variable, we expected to get false as a result of check if sleep time is greater than psat time. Another example is assigning two different Boolean values into two different variables. The result of applying logical AND to both of them is false, since one of them is false. Now let's take a small break and consider this labyrinthine game. The character in it can decide which way to move on the next step. Here are some possible rules we can introduce for the game logic. In case it's clear to the right, go right. If right is blocked, go forward. If front and right are blocked, go left. And in case right, front and left are all blocked, we can go back. Imagine we are programming our game in Python and we can use an if statement to implement this logic. There are three variants of if statement syntax. The most simple one is the following. We check for a condition, which is some expression always interpreted as a Boolean. In the case condition is true, the inner code block shifted or indented to the right of the if will be executed. In case condition is false, interpreter won't go inside the if code block. Second variant is used when we need to do something else in case our condition is not met. As you can see, an else keyword is added with a code block under it in this case. Finally, third and the most complex variant allows us to do several sequential comparisons, stopping in case any of them returns true. It also can have an else section applied when none of the conditions is met. There is no limit on how many else-if code blocks you can add. However, it's not recommended to check for too many variants with such syntax. As you could saw in our previous example, indentation really matters in Python. It's aimed to tell the interpreter how we compose the code in blocks, creating structures of our program. As you can see, in this example, on the first comparison of the if statement, we have a code block indented to the right, and this code block we also have an if statement within a code block. So, indentation allows us to nest code blocks one into another and create our code hierarchy. It's also worth mentioning you should always use same number of spaces or tabs for indentation everywhere in your program. Now let's see how these visually similar operations differ. A single equals character stands for assignment, as you probably know already. However, it's too easy to mix it together when using with if statement. You should always use two characters equals operator when comparing values, since otherwise Python will think you are trying to assign a value to a variable and will give you a syntax error. We now know how to run some code conditionally with if statement. But what if we need to run some code for a number of times based on a condition or unconditionally? Python loops will help us with it. The first loop construction is a while loop. You should specify some condition after a while keyword, just like with the if statement. The difference is the code in the inner block will be executed iteratively while the expression provided for condition is true. In other words, everything inside the loop will be repeated until the condition is false. Here's a while loop example. We have a program imitating a game when on each step the user is asked with which direction he or she wants to move next. The code will run until the direction user enters is not right. In this case, the loop stops and program ends. There's another loop type in Python called for loop. Consider the following two code samples doing the same thing. First one is implemented with the while loop. We need to assign an initial value to the variable n and also explicitly change its value inside the loop, so finally the expression we specified as loop condition is false. It's much less wordy when using the for loop with range function, returning the next integer value in the sequence on each loop iteration. Here's the general syntax to be used with for loops. You should declare a variable with the for loop param, taking values from some list of values. In case we are iterating numbers, we can use range function to generate a list of numbers. On each new iteration, the variable takes next value from the list. The loop ends when all values in the list are processed. Let's check the range function more deeply. It can accept up to 3 params: start, stop, and step. In case 2 params are provided, the first one is used for start and second for stop, and default value of 1 is used for step. In case only 1 param is specified, it's interpreted as a stop value, so start value is 0 by default. Here's one more useful Python statement, break. It allows you to end the loop prematurely and skip remaining expressions in the code block, so the loop execution is immediately stopped. Please note, when you have nested loops, it only exits the inner mode's loop or if code block where the break statement is called. Consider the following example. We have an if statement called inside a loop. Calling break inside if code block will stop its execution and return to the next iteration of the outer loop. Let's compare features of for and while loops. In for loop, you know the number of iterations, and in while loop you can have unbounded number of them. Both for and while loop can end early via break statement. For loop uses a counter or a loop param variable taking value from a list sequentially on each new iteration. While loop also can use a counter, but need to explicitly initialize it first and change it inside the loop. Common mistake is omitting loop param increase or decrease in a while loop, leading to an infinite loop execution. Finally, you always can rewrite a for loop with while loop syntax, but not the other way, since while loop is more generic construction. Now, you could say you know much about strings, code branching, and loops in Python. More in our next videos, so stay tuned.